All right, so let's look at a few examples going over identifying our sequences. Now remember, sequences are just part of those families of functions that we've been looking at from yesterday and today. Okay, so looking at this, we're going to start with finding our pattern that we're looking for in our problems. Okay, so if I look at this one, to go from 192 to 96, okay, we don't want to say we're dividing by a number or anything because we are getting smaller. So it's our natural instinct to say we're dividing. But remember, for our functions, we have to say we are multiplying by a fraction. So to go from 192 to 96, we are multiplying by 1/2. To go from 96 to 48, we are multiplying by 1/2. And 48 to 24, we're multiplying by 1/2. Okay, since we are multiplying by a number, we're not adding, we're not subtracting, we're multiplying, okay, we know that this is going to be an exponential function. Okay, we know that this is going to belong with that family of exponential functions. Okay, so when we're talking about the sequence, because if we're just talking about a list of numbers, that's our sequence. Okay, so for our sequence, we have two options. They're arithmetic or geometric. And remember, anytime we're multiplying, that's going to be a geometric sequence. That E turned out weird. There you go. Yeah, that's a little better. Okay. Now, whenever we're looking at our common whatever, it's either our common ratio or our common difference. Okay, here we're multiplying, so remember that means we're talking about a common ratio. Okay, and we're multiplying by 1/2, so our common ratio is a 1/2. All right, looking at the next one. Okay, we have the sequence 11, 6, 1, -4. I want you to go ahead and try that one on your own, and then you can check your work with mine when you're finished. All right, I hope you took the time to go ahead and do that one on your own. If you look at this, we're not multiplying by anything anymore. To go from 11 to 6, we're subtracting 5. 6 to 1, we're subtracting 5. 1 to -4, we're subtracting 5. Okay, since we are subtracting by the same number every single time, okay, that means it belongs to that family of functions called linear functions. Okay, so we could compare this to a linear function. And since it's linear, the sequence type is going to be arithmetic. Okay. Now, since we are subtracting, anytime we are adding or subtracting, we're looking for our common difference. Okay, and if I look at this, we're subtracting 5 each time, so my common difference should have been a -5. All right, if you have questions about those two, make sure you let me know. Looking at the next one, now we're going to actually be graphing these. So looking at what does a sequence, the graph of a sequence look like? Because they're a little bit different than functions. They still look very similar to our functions, but they're a little bit different. So first, we need to determine, are we dealing with an arithmetic or a geometric sequence? Right off the bat, we should notice that, hey, there's a G right there. So there's a good chance we're looking at a geometric sequence. If you didn't notice, you could have checked to see if we're multiplying by anything, which we are. To go from 1 to 3, we're multiplying by 3. To go from 3 to 9, we're multiplying by 3. And 9 to 27, we're multiplying by 3. So my sequence type is going to be geometric. Now, since it's a geometric, we know it belongs to the family of exponential functions. Now we do have to graph this. So remember, this is just like our x's and our y's pretty much. So we're going to start with our x-axis. We always start with a 0. And we're going to go 1, 2, whoops. I'm going to space that out a little bit more. So 1, 2, 3, and 4. Just to give myself a little bit more room. We're not going to call that the x-axis, so we need to label it our n because we're talking about the nth number of terms. Now on the y-axis, that's where we're going to call that g of n. So that actually is telling you what that term represents. Okay, and we have to get all the way to 27. So I'm going to probably go up by 5, 10, 15, 20, 25 is going to be close. So I'm going to go up by 5s. All right. So now we're just going to graph our pieces. Now, I know it's going to take a little bit of estimating, but that is totally okay. So the first point we have is 1, 1. So that's going to be about there. The next one was 2, 3. That's not bad. We have 3, 9. And then we have 4, 27. Now that one is going to be off the graph a little bit, but that's okay. I'm not going to be too picky about it. All right, so looking at this, we do not connect all the points because the sequence is just those individual numbers. Okay, so we only want individual points. It's only functions that we connect everything because that's where we're talking about all real numbers. Sequences, we're talking about the individual numbers on our list. All right, so then last one, a little bit of review. Determine whether each of the following is linear, quadratic, or exponential, or none. So if I look at the first one, I've got y is equal to 7x times x minus 3. Well, remember, we have to simplify these if ever we're looking at if it's exponential or to determine which family it falls into. It needs to be simplified. So I'm going to distribute that 7x. Well, 7 times x gives me 7x squared. And 7x times a negative 3 gives me negative 21x. My largest exponent is a 2, so that means it's quadratic. The next one has a largest exponent of a 1. Well, we said, remember, largest exponent of a 1 is going to be linear. Now, on the next one, we have x times y is equal to 2. Well, that does not look anything like any of the functions we've dealt with at all, okay? So, since that doesn't really fit into any of our categories, that's going to be none. Because that's where your x and your y are being multiplied. And anytime that happens, that's not going to be one. Oh, I forgot the e. My bad. The next one, we've got y is equal to 2 divided by x. None of our functions have we ever divided by x, okay? So that's also going to be none. Okay, that doesn't fit into any of our families. The next one we got is f of x equals 5x, or 5 to the x power minus 1. Anytime your x is an exponent, it's exponential. Okay? Remember, we got to remember that. Anytime your x is an exponent, it's exponential. All right, we're going to go ahead and stop there for today. Okay? And if you have any questions about your sequences, just let me know. If not, you can move on to your assignment.